All right, so we're in the last week of school. And what we're going to do this week is I'm going to give you guys practice just putting all of the topics from our class into practice, um, not in a sort of high tension environment. I want you to actually just feel free to experiment, to get practice designing things, because architecting big software projects is hard. And so uh, writing little 5, 10, even 100 lines of code programs is nothing, right? Like you can just spit that out, not a problem. It gets harder when you've got multiple pieces that are all kind of working with each other. And, Bob's in charge of this thing and you're in charge of this thing and you've got to call his API and then he changes his API without telling you and all your code stops compiling. Um, and so these challenges actually become quite real, and you don't really get a sense of what real life programming is like from just doing college little toy programs. Even something like Huffman coding, is not really um, giving you real world experience. So what we're going to do this week is we're going to do in right. That's funny. We're going to do in class exercises. And I don't want this to be the thing where I'm like we're gonna do lab time and then people click the disconnect button and go off and play video games. I want you actually in class working on your particular block of this large thing that we're going to be doing. And the thing that we're going to be doing is we're going to be writing code for is that screen moving? Yeah, it is moving. That's so weird. It's disorienting. It's like you're on a boat. It's so weird. Uh, like the person's drunk slightly, doing some Hanami or something. I don't know. So, so the application that we're going to be doing this week is going to be software for a grocery store. This was you're nauseous now. Yeah, it's kind of bugging me too. Let me switch it up. So I would like for all of you to think about what kinds of software goes into making a grocery store work across the board. And so just on Discord right now, type up some ideas. What kinds of things, from a software perspective, does a grocery store need to keep track of? What kinds of places do computers interact with real life in a grocery store environment? How do customers interact with the grocery store through computers and other stakeholders, as they call it in the jargon as well? And so we'll come up with maybe 5 or 6 different areas that needs to be. How about this one? There we go. This one's not moving. It's warping a little bit, but okay. So go with that. So think about it. Like your last name is Vaughn's, or your first name is Save Mart or something, and they're going to have programmers working for them. Every major corporation has programmers working for them. A lot of times they just have database people and web people, but at a certain level you're going to have code written for you. So social security numbers, payroll, employee login, inventory payments, inventory, stock items, clock in, so time, like timesheet kinds of things where you can clock in, clock out, and do payroll, basically stock items. Register tills, yeah. So you need to have a point of sale (POS) system that will tie in with the inventory system, right? So you have inventory that tracks everything you have in the store. Every item in the store is going to have some sort of UPC code, which is a number. And things that don't have UPC codes are like produce and things like that have their own code. And your point of sale system mostly just scans the UPC numbers and says, okay, you bought a box of, trash bags, you bought, a styrofoam tortilla warmer, which I saw at Save Mart yesterday. And then it just adds that to the bill, and then the person paying, the customer paying, oftentimes will punch in their phone number, so there has to be some sort of customer loyalty program that will attach the purchases to the customer. Coupons have to be handled. Somebody has to be able to make coupons and print coupons, and you have a print thing. But like when apples come in, the person will enter the code 1234 or whatever for an apple, and then weigh it, and it looks up the price per pound, and the scale multiplies together to give the price on that. Financing, I don't know about financing. Maybe if you're like at a Costco or something. Waste for expired items, yeah, that's probably something to track too. Secure transactions. Yeah, there's a big issue on how you can secure people's passwords, credit card numbers, things like that. And in 2013, Target had a massive data breach, and Target settled it for $18 million. So 40 million credit and debit cards had been stolen. So like more than 1 out of 10 Americans had their private information stolen. And they were doing some really bad things. Like they were actually storing the credit cards in like plain text, which is a no-no. If you ever worked with anything like involving credit cards, you know you are not supposed to write down people's names, credit card numbers, CVVs, and expiration dates, and they did in plain text so that the hackers could come in and steal it and then start charging whatever they wanted on the stuff. So, so how you handle that is there's a couple different ways. You can get like if you save your credit card information with a website, it connects to Visa, and then Visa gives you back a token that you use rather than storing the credit card number itself. And then if somebody steals that token, it doesn't work because it only works on the website that it was granted to. So that's one way of doing it. Another way is you can store things in it using a hash. Right? We've talked about hash tables this semester. So like if somebody types a password in, you hash the password, and you store this big long thing. And on the server, I think there's a function to do that. 2013, yeah, not too long ago. Way after the point that everybody knew better than to do that, Target did it. And I had a friend who would travel from place to place and audit people's websites and mainframes and whatever, making sure they weren't doing exactly that. So the fact that Target was doing it is worrisome, to say the least. So there's a function called crypt, and you can give it a password, and it'll generate a encrypted version of the password. And it's not really encrypted per se, but what it is you only have to save the crypt version. It's basically a hash, right? So yeah, you can see it's actually using a hash here. And rather than like going into a hash table, what it is, it's a one-way function. So if you type in puppy as your password, it'll give you blah 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 blah, like looks like random garbage, 56FF2Q. And nobody can take that hash and go backwards with it. So they don't know because of that string that you typed in puppy. All they can do is guess words and hash them and see if they match. So if they guess puppy, they'll get the hit and they'll know what your password is. But they can't just they can't reverse it. They can't go backwards. So whoever it is that's going to be implementing, passwords and social security numbers and things like that, you should probably be encrypting them using some sort of hash function. We don't need the most secure things here. We're doing a little class project. But yeah, you shouldn't be storing any of that stuff in plain text. And so if you want to check to see if somebody's going to log in, what you do is you save the hashed version of the password, and then when they log in, they type in a password, puppy, you hash it, and you check the hashed versions and see if they're the same. If they're the same, congratulations, that's the right password. But you don't actually know what the password is. All you have is the hashed version of the password. So you use crypt, or you can just use std hash if you want. Can you RSA encrypt credit cards? That doesn't make a whole lot of sense, because the whole point of a credit card is, you need to be able to get the credit card number. And so, what happens is, like if you have a chip or something like that, then what happens is it goes through like a cryptographic authentication system, and that will authenticate the card. But the old system of just having a credit card number is incredibly insecure, and anybody who gets a copy of it, like if you use a credit card skimmer Like you go to the gas station, you put it in, you feel a little resistance, you put it in. That's probably a skimmer that just read your number, and then they're going to go out and run up the tab on your credit card. That's why the chip systems are in existence now. But not everybody has switched out of card readers, so we still have them, even though they're not very secure. All right, so let's write down some ideas here. So BIM, grocery. Let's get some grocery. Okay, how about that? All right. So what kinds of systems do we need? We need inventory. Okay. Memberships. Customer loyalty. Customer loyalty, and ID theft. Tracking customers. Financing, coupons. What are some of the other things in here? Employee login. Time card. Payroll. Point of sale. What else? App. Yeah, so doing some sort of like Instacart or DoorDash, groceries, app to order, curbside pickup. What else? Anything else you can think of? One of the students in the previous class worked at a bakery at Vaughn's, and so he says you need a label printer. The employee selects the item in the database and prints a label for it. So like you order a half sheet cake, they select that in there and prints out a label, and you slap it on the thing. Ordering system for new items, yeah, okay. And so, yeah, a lot of these things are going to tie in with the like inventory system. I think the inventory system's probably the most important, and then maybe the employee login. You're probably going to have 3 different databases: one for the items that are in your store, one for your employees, and that's going to track everything from their name, their pay rate, how many hours they work, things like that, clock in, clock out, and your customers. So customers' name, address, purchasing history, things like that, so that you can sell it to Google. Social credit score. Right? Okay. So what I'd like is for everyone... Okay, so what you're going to do is you're going to work on just one of these things. And we'll like divvy them up among people, and you can work in a group. But I want you to sort of design them. I'm not going to tell you which data structure you should use. You should look at it and be like, maybe this sounds like a queue. Maybe this sounds like a hash table. Maybe it sounds like a vector. I want you to talk amongst yourselves what data structure is appropriate for it, because that's kind of why we're doing this accumulating activity. Maybe another one would be like track which registers are in use. Display red, green graphics. Which are open. So like a manager could see like 3 people are logged in right now, and they like peek out like, oh, the lines are pretty long. Hey, somebody go to registers 4 and 5, that kind of stuff, like a manager dashboard. Three students each. Okay, yeah, that sounds good. Work amongst yourselves, and you can set up a private chat amongst yourselves and talk about it, and then you're going to start implementing it. And you might be like, wait, if I'm doing the the point of sale, I don't have access to the employee database thing. And so what you're going to do is you're going to mock the connection. That doesn't mean you're making fun of it. That means you're going to pretend that it works, right? And so whoever it is that's handling the employee side of things, where they clock in, they clock out, they have a username, login, all that kind of stuff, they're going to be doing that. And they're going to provide an API. They're going to provide an application programming interface. In other words, a function that you give them a username and password and it returns back true or false or whatever. Yes, they're logged in. Or the employee ID probably. Yes, that person is now logged in. If you're doing the point of sale, that's not your job. That's the job of the employee database person. So what you're going to do is you're going to mock it. And so you're just going to assume, like, you're going to have a function call to, like, log in, and then it will return true. Yes, you have successfully logged in. You know, you're going to pretend that it works until it does work. And when it does work, you're going to connect them. But in the meantime, you can just go about your business programming your thing. And that's one of the really nice things about object-oriented design is you can sort of separate out the parts that people are working on, and before a part's done, you can just sort of pretend that it works with just some dummy function, before, you're doing a point of sale and somebody rings up apples, maybe you do a database call to the inventory people. Number one, hey, what's the price of apples? And it doesn't exist yet. And so you just have it randomly make a price for you, or something like that, right? And so you mock the connections until they're ready to be integrated, okay? And so you can just work on your part and test it and make sure that everything works. And then once the inventory people have got their API in, then you can contact it. They'll send you back the price of an apple, and then you can tally up the results. And then when they check out, you add together all the price of things, print a receipt, send it off to the customer loyalty people, like, hey, this person bought this stuff. And you send them a list. Maybe that doesn't work yet, so it's just a function call that does nothing, right? You just pass it a vector or whatever. Here's everything they bought, and you call a function that does nothing. But that's good, because whenever the customer loyalty people get their work done, then all you have to do is put two and two together, and then it works, right? Or oftentimes it doesn't work. Oftentimes there's integration issues, like the customer loyalty people were expecting a BST, and you give them a vector, and then it's like, and so a lot of times you need to talk to the people, but in general, once you agree on an interface, like, I'm going to take a vector that contains, a vector of items, and the items are a IPC number and a price or something like that. And then as everybody agrees on the interface, then everything should go smoothly. It doesn't, but it should go smoothly, right? Encryption for membership and customer loyalty. You don't have to, but I'd probably do it. At least use std hash. Just hash it. Just make an effort. Okay, so do you guys understand what we're doing here? And so we're gonna work on it in class today, and you're gonna design your part of the system. You're gonna talk to the other people. And if you have to, like, hey, what's the name of your function going to be? And you just mock it out in the meantime. And it is cool. Yeah, that's the idea. I want you to get a little bit of experience working on a multi-team project, which is how it works in reality. You're very rarely just a person in your basement, coding. You're usually working with a team, and then your team's working with other teams, and communication is a thing. Like, programmers have to be at least somewhat social, right? Like, if you don't talk to anybody, you're not going to be very popular because you're just doing things, and you're doing this in C++. You're doing it in C++. Not pseudocode, not Java. Doing it in C++. So so you'll get experience designing things, implementing them, choosing which data structure you want, and hopefully putting together a system that's pretty cool. And we'll continue this on Wednesday with some other stuff. I have a topic I kind of want to go over on Wednesday, but for now, I think this is a good place to kind of turn you loose. And what we're going to do, Minkrelli and I, is we're going to hop in on each of the groups. So I'm actually going to create like some voice channels here. So I'm just going to create like a voice channel. So this will be inventory channel, and I'm going to throw some people in that. And if any of you have anything in particular you want to work on, let me know. Otherwise, I'm just going to sort of randomly assign you to things. It's like a Zoom breakout kind of thing. Oops. It's a text channel. And then Mint Corelli will just be hopping. Mint Corelli and I will be hopping in and seeing what how your design process is going, how you're coding, that kind of stuff. Okay. Surprise you. Make it random. 2, please. What do we got? And I've deliberately left this like kind of vague. Like I'm not, because I'm trying not to design it for you, right? I'm trying to actually get you to like kind of think about what are my requirements, what kinds of things do I need to consider, you know. You know, if it, like, for example, if you're working on the manager thing, what kinds of things would a manager need to know about the grocery store? You know, maybe things you're out of stock on, like who's at the POS machines, and that's kind of the mindset, right? So, okay. So Holman and Otal want number 2, okay, which is what, memberships, and just join in yourself. Holman, actually, memberships, there we go, and Otal, I can't scroll, why can't I not scroll? There we go. Okay, and then everybody else, you're just going to get randomly assigned to things. Okay, so I'm going to pause the recording here, and let me divvy you guys up.